สวัสดีครับ Good morning, everyone. My name is Akaladesh Smersuk, or you can call me Joe, J and O. I'm a PhD student here, and I will be your TA this semester for the machine learning course. For this today, we have a boot camp, and I highly suggest everyone use a laptop and work with me. So at the end of the day, you will have a Python environment and you can run Python code. That's the main objective. So when the semester starts, everybody should be able to run Python. No. Is people from online here? What I say? Do you hear me? Can you say something, people in online?
Yes, I can hear you.
Okay, thank you. Wait a minute, we have. Ow. Where did he go? He left? He left? There is a person open the door. He left? Okay. If you cannot hear me properly or if you have questions during this workshop, just scream. Raise your hand, scream, make me stop. I'm willing to clear your undoubt or go repeat myself again. Account for Wi-Fi. Thank you. Account for Wi-Fi. I guess I should start with welcome to AIT. I hope you enjoy your life here from now on. Okay, share my screen. Screen one. Right. Okay, so for this morning, we will go through what the thing that's called Docker. Docker. This is Docker, the program that's called Docker. Previously, if you have been writing codes previously before you come here today, you might have an experience installing Python or C# or some other IDE or some other programming language. But for those who don't have those experience installing program or compiler or interpreter is fine. So today we start fresh with Docker. Docker is basically a virtualization program. So we're going to virtualize the kernel, the thing called kernel, or in the basicer word is we virtualize or simulate Ubuntu, Linux. So if you have a window and you want to be access to the library or the terminal of Ubuntu, you can do that via Docker. But if you already have Ubuntu, you might not need to install Docker because basically you have the same environment, but still because of the virtualization things, we separate the host environment from the developing environment. The other way to see it is the Docker container is a sandbox such that your code live in the sandbox. And every time you don't need to use this code anymore, you just remove the container. And there is no way the container or the code you write in the container interfere with your host. So it's separate. Previously, if you write bare-bone Python without Docker, your code exists in the host system and it uses the host hardware, but now it's used container, the thing that we are virtualizing. So the best benefit for now to easy understand is when you install container and you don't need it, you remove it, or something wrong with the container, you just recreate the container. Just like when you have Ubuntu or you have Mac or you have Windows, you start installing a bunch of software and basically you don't want this hardware or you don't want this window anymore. You just reinstall the window, get a new fresh window. So in the same way, when you have a container and you want to fresh start, we destroy the sandbox and build things from scratch, but it will be very fast. So it's, yeah, we start from there. Okay, so that's how we imagine. So you can imagine that we're going to build a sandbox and we have a Python inside. So you can run Python inside the container, not from your host. Okay, you new? This Wi-Fi account. I would like everybody to access this Docker website. And for those who use Windows, you install the window. Yeah. And if you have Mac or Ubuntu, or if you have Mac, you also use this button to download your Docker desktop. Here, if you use Intel Mac, you use this one. If you use M1, M2 Mac, you use this one. If you are Ubuntu user, I'm not sure. Last time I used Ubuntu with Docker desktop, it doesn't work. But it might fix, so you can try, but I'm not sure. In Ubuntu, I normally just use Docker without Docker desktop. Okay, so I'm going to install the Docker desktop. By the way, my computer is fresh installed. My Windows is just installed last night. So it's like I'm building the Docker and everything with you today. There will be a lot of waiting today. Okay. I think if you use Mac, you don't need to restart, but if you use Windows, you need to restart. So I'm gonna click restart. Bye-bye. Okay, my computer is back. Back sharing the screen. Okay. So when my computer restarts, this is what I see. So the Docker automatically starts and it's prompt me this window. I just click accept and there should be this window pop up. And if you use window, you should also see this message. You can install Docker. You cannot install Docker, or you can. Cannot. What do you use? You use Docker Desktop, or you use Brew on the official website. Can you wait? I'll finish this and then we'll go to you. Okay, so for Windows user, you have to update the WSL, which is Windows Subsystem for Linux, blah, 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 blah. The thing's very not complicated, but ow, where's my, ow. Hey, come back. Okay. Keep going away. Okay. So all you need to do is type WSL -- update in your terminal or in your command prompt. So open your command prompt using here and type cmd or find command prompt. Click the command prompt. You should see this in this window, or you use if you are the shell user, then you use PowerShell. It should work the same way. PowerShell here. I don't know which it should work. Okay. So when you have a the WSL, you can try use the WSL command here. Okay. Dash L. Oh, dash U. Dash list. Yeah. Basically, I have the WSL. So I reopen the Docker desktop. And this time it should not complain. Please not complain. Hey, it seems like it's happy now. Right. So when you fresh with the Docker desktop, this is the first page you should see. So this is basically you have a Docker. The way to reconfirm that your Docker is running is go back to your terminal or PowerShell or terminal in Mac and then type Docker. And it shouldn't come up. You should see something like this. Usage Docker, blah, 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 blah. Or if you hate this, a lot of text, you can type Docker PS. And this should show up. If you use Mac or you using Ubuntu, I would like you to confirm that you have Docker Compose at this stage. So Docker Compose. Docker Compose. If it doesn't work for you, then try Docker-Compose. Sometimes it needs the dash, sometimes doesn't need the dash. Okay, so this is basically you have a Docker. It doesn't look amazing yet. The next, we want to try to see whether your Docker can run the thing called image. So we type Docker run hello-world. So when you click enter, it will say unable to find the image. And then if I wait, it should download the image from a Docker Hub. Please download from the Docker Hub. I think I got kicked out from the internet. Oh, hey. It didn't take this long. But my terminal just hang. Okay. So if you run Docker hello world, then this should prompt hello from Docker and a lot of other text. So this is basically a welcome message from Docker. And it's trying to explain what it just happened running hello world like this. So basically what it happened is, this is the image, and I will explain what is going on. But what it's trying to explain here first is download the image from the Docker Hub, and then it's run the image here, and this image outputs these message. So now we have three terms: Docker Compose, Docker Hub, or four, including this one, is Docker Desktop. Okay, so everything is Docker, but it's everything is trying to work on Docker, but it's just different UI, different interface, but everything is Docker. Okay. Okay, so I will wait here and make sure that everyone can use Docker run hello world, and you see this message, and then we continue. Okay, so it seems like everybody can run Docker run hello world, and everybody in this room. I'm not so sure whether people from online can do it yet. But if you have problem, just screen from the online. Okay, so now I'm gonna try explain what is Docker in by drawing something. Which way is better? This one? No. Okay. So first we have Docker. The Docker itself is a program. Just like when you install Line, you install Chrome or those things. So that is Docker, it's a program. Currently, we are interacting with Docker via two-way, a command line interface. And the other way is Docker desktop. So in the command line, what did we use? We use Docker. Oh, my handwriting is so bad. Docker, yes. And there will be a bunch of other Docker, blah, 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 blah. All of these is a command. And normally we are bad at remembering command. So instead of remember on the command, or you spend time remembering command, we can use a GUI, so you don't have to remember the command. So that's why we have Docker Desktop. A Docker Desktop is a GUI interface, so you can interact with the Docker without remembering the command. So basically the two things are not similar, but the Docker Desktop have the ability to control the Docker by just clicking. And there will be other utilities come with the Docker Desktop. Okay. So that is just from the start. And then now I'm gonna try to explain the component of the Docker. So when you run Docker, when you run this command, the Docker say it cannot find the image. So this is the first term, image. So what it has to do, because it cannot find the image in your computer, it fetch the image from online. This online is a Docker Hub, another term, Docker Hub. A Docker Hub is a website. The correct term of the Docker Hub is repository. So it's contained a bunch of images people upload, and then you just download those images. You can just use it. It's like YouTube, where people upload video, and then you just click and watch. So similar things here is the Docker Hub have. all the images and you just download. But the correct term to use is repository. So repository. So here you will have the image called Hello World. And some other images. So this command, because cannot find, so I fetch this one and copy these images to here in your local. And then what happens next is run this image. And after the run, what you got is a thing called container. Every time you run an image, you got a new container. So if I run Hello World again, I will got a new container. And if I run again, I got a new container. So if you keep running, you will have like 100 containers that you never use again. So now I'm gonna try and explain what is image and what is container. What I use to compare into what you probably be more familiar is an image is like your ISO file. So normally if you want to install Windows or install new Mac OS, install Ubuntu, you have to go to those websites, download the thing called .iso. And then you build your USB bootable thing, and then you install it into the machine. This same image, window.iso, ubuntu.iso, you can keep install into a new machine. You buy a new laptop, you install it. You buy another laptop, you install it. When you install it, it's like you execute the run. So your new machine become similar to container. Every time you install the ISO, you have new container. Every time you install the ISO, you have a new machine. So this is like your laptop 1. This is laptop 2. Or this is super rich laptop 3. So similar. So if this image is a window image, window, then this will be my window 1, window 2, window 3. At this stage, after the run, or after you just fresh install the window, the laptop is similar because it has the same, it will have the same library, it will have the same set of program, it will have everything the same, like the driver and everything. Until you connect to the internet and the Windows start installing automatically new updates, drivers, you start install the Chrome, you start install other program. Then these container or these machines are no longer similar. So it's a different instant now. One day, if this window is broken, you just throw it away or it's crash or anything. In the same sense, the container can die. So you destroy the container. When you destroy the container, this no longer exists. You basically throw away that laptop and then you buy a new one because we are very rich. And then we fresh install this and then we build another machine, install the Chrome and everything again, and then we use it. Once we bored with it, we destroy this, buy a new one. Every time we buy a new one, and we install a fresh program, it ensures that there is no conflict. If you use a window for a long time, there will be a registry everywhere. You install this program, install the other program. Sometimes the library can crash and conflict, or you probably heard that your window is slow over the time. If you fresh install the window, then everything just works. So in the similar fashion, we want to fresh build the container and ensure that this fresh container can run the program instead of hoping that it can run. So we build the container so we ensure that it can run the program, not hoping that it can run. Okay, so this is the key. We ensure that it can run the program. So right now, when we install Windows, it cannot run the program. So that's why we need to install Python, install other stuff, so it can run Python. So it would be better, instead of install Windows and then install Python, we have a custom window image. I'm gonna name it window_Python. And once we install this image, or we run this image, the container can just run Python. We don't need to spawn the container and then install Python. After we install the machine or run the container, it has Python right away. So we built image. This is called build. And this is your new image. There's no meaning to the color now. I keep changing colors. Okay. So now the image of window and the image of window Python is not the same anymore, because we customize the image Python and the image window_Python. So people who use Windows to run the container, and another one who use Windows Python to run to start the container are no longer the same, because the image has different set of program and libraries. Okay. Right. So now we're going to build the image so it can run Python. Stop share. Okay, but before we build, we should install the thing called Visual Studio Code. So we have a program to write text or code. So I get over ahead myself. So we go here, Visual Studio Code. Here. And then it just shows the version that appropriate to your OS. I have Windows, so I click this one. What we are downloading, the correct term to use is the ID. I think it has to say somewhere that it is the ID. Okay, it doesn't say so, but it is one of the IDEs. So what it does is a text editor at the basic point. It's a text editor, just like Notepad. You have Notepad, and then we edit the text using this one. So Visual Code can edit the text. But instead of you just write the text, the Visual Studio Code can help you write the text. If you write Python, it can help you write Python by make suggestion, help you detect some errors, help you run the Python. So if the Notepad can do such a thing, it is an IDE. So it's not just a text editor anymore. It's text editor with some other thing that help you write help you develop code. And then so these two things, when you combine, we call it IDE. If you write Python before, then you might use something like PyCharm, which is another IDE specifically for Python. If you're very old developer, you might know Sublime. Yeah, this is another text editor. It's not yet an IDE because it's not helping you run Python. So it's just a text editor. Yeah, text editing. I used Atom before. Here there is this Atom. But I think since like 5 years ago, people shift to Visual Studio Code. So this is like the godsend text editor. And basically you don't need, it's your final text editor because it can do everything. I'm gonna install VS Code. Okay. So this is the Visual Studio Code. It's very dark because developers like dark window. They don't like bright. But if you are happier person, you can just click here and then turn everything to bright. So make your life brighter. But I'm sad, so I'm gonna use that one. Okay. Visual Studio Code is highly customizable, so you can like adapt this one to fit what you want. Instead of you adapting yourself to Visual Studio Code, you can configure the Visual Studio Code such as it's adapt to you. And these are the customization that is trying to lure you into the customization rabbit hole. But I like to use everything default. Okay. At the beginning, I'm gonna pick the folder where I want my code to live first. So I'm gonna find folder. I don't have folder because I haven't created one. This is up to you, but I'm gonna put it here. Right. It's so this what I imagine is here in this folder, I will have project 1, project 2, project 3 for different projects. So all my projects will be here, live here. So I'm gonna call this bootcamp. And then I'm going to open this one, open folder, open bootcamp. Okay. So what we are going to imagine is this will store our source code along with our Docker image, Docker file, Docker compose. So every project will have its own Docker to run. We don't use one Docker for every project. So it's the same way, in the similar way, like that you are very rich, so you buy a new laptop to run a specific one project. We want it that way, even though it's going to use a lot of hard drive, but it's make your life much easier. In the IT world, the hard drive is very cheap. So we don't care whether we use a lot of hard drive. We're gonna care eventually, but for now, you don't need to care that you use too much hard drive, or you keep building an image, you keep downloading the image, and it just takes 30 gigabytes of your SSD storage. The storage is cheap. We consider it cheap. So the Docker build it this way. It just use your storage, but we're going to manage it eventually. But for now, if you think we just keep downloading image and take all your hard drive, the people here, the developer just think we have this instinct that hard drive is cheap, so just use it. So Docker have that philosophy. You just keep using your hard drive. So eventually you have to go and remove some of the file from Docker environment to gain back the storage. So every project will have its own image, just like in the same sense, just that when you just buy a new laptop and make sure that laptop just run one project, and it will just run that project only. We don't use one image for 20 projects. We use one image for one project. So there will be a pair of projects, an image, project and another image, project and another image. Okay. The first thing we're going to do is go to here, extension. Now we're going to make Visual Studio Code understand Docker. At the basic, Visual Studio Code can do nothing, just edit the text. But because of the extension, if you want to write Python, you install Python extension, then it understands Python. If you want to write JavaScript, you install a JavaScript extension somewhere, then it understands JavaScript and can help you develop a JavaScript. Now I'm going to install Docker, so it can help me developing Docker. If you cannot find Docker, then you type here Docker. And it should be this one, the one with the bash. Click install. Now we have to wait again. Okay. So once you install this extension, this logo should appear on the left. So we click this one. And this section adapt to the tab you click. So this one become a Docker sub window. And what I want to show you here is it has a containers, and it lists all the container in your computer. It has images, and it lists all the images you have locally in your machine. And some other things, which is very similar to Docker Desktop. So if you come here, you have these tabs: containers, images, volumes. So if I click containers, I will have 3 containers, and the name is supposed to be the same. Hello. It's the same name. Yeah. So whole food, blah blah blah. Here, whole food, ramen, what? Ramen, whatever. It has the same name. It's basically now the Visual Studio Code become a Docker desktop. So if you hate this screen, you can just use this one. So what I meant last time when you run a container or when you run an image, you make a new container. So I run hello world 3 times. So I have 3 containers. And if I keep run this hello world again, I will have a new container. Right? Because Docker don't care about your storage, just keep using it. So now I want to remove this container first to gain my storage back. So you can use command line, but I'm gonna do this, right click and remove. And all the container is gone. And if you don't use hello world anymore, the image, you can right click and remove. Then I remove the hello world image that I just downloaded from the Docker Hub. Before we continue, I would like to introduce you now to the Docker Hub. So Docker Hub. A Docker Hub is where people build the image and then they upload the images. So you can just use it. So I can find hello world here. Hello world. So this is the exact image we just downloaded when we type Docker run hello world. This is that image. There are other images if you want to run database. If you want MySQL, you can find the image of MySQL here. And then you can just pull MySQL, and then you have MySQL image. Then when you run MySQL, you have a database. So you don't need to find MySQL, install your MySQL in your Windows, Ubuntu. So this is another way to have MySQL. If you don't like MySQL, then you can find Postgres. Yeah. So we want Python. So I'm gonna type Python. And then there is an image specifically built for run Python. If you don't care, you can just use this command, docker foo Python, or you can just run Python here. But I don't want you to do this yet. I'm gonna show you that you can use this, and then you're gonna fetch the thing called Python latest. And when it's finished the run, I suppose you have nothing. Okay, so now it's pulling Python images from the Docker Hub. It be faster, please. Okay, so yeah. So what happened is I run Docker run Python. It's trying to find the Python images with latest tag, with latest, but it cannot find on my machine. So it download or pulling, because it's repository, the correct term to use is pull. So it pull the image from the repository, which is Docker Hub. Once it's downloaded, then it's run this image, but nothing happened. So this is not the same as the hello world. The hello world, once it's downloaded or pulled, it print a bunch of text. But Python here is the image. That one is once you have the image and then you run the image, it does nothing because we haven't asked it to do what. So it's just an image. Once it's run, there is nothing inside. Okay. So what happened here is I use Docker run Python. First, I don't have a Python image, so it's pulling a new Python image from a Docker Hub. This is the log. Say it's trying to download, and once it's finished the download, this is the log. Say, okay, now I have my machine have Python. Then it's run the image, but nothing happened. So this is different from when you run the hello world. When you run the hello world, once you finish the pull and then you run, it's print a bunch of text for you to read. So this behavior is because of the person who built this image has write a command to specify what to do when you run the image. So in the hello world, there is one line say, when you run, execute this. But in Python, there is no that command. So nothing happened. So in this image, when you cannot just run, because it's only have the library, we haven't asked the image to do something yet. So because I run and then I pull, now I have the Python latest. And because I run, I have a container Python. A container named this, which is based on image of Python. This is the same information here. Okay. Before we go next, we have to ask ourselves which version of Python we want. Because here we just pull a Python and we don't know what is the version of it. If you don't care and you just want Python, you can just use the latest one. It should be fine. But I want you to be in a good practice. So you have to consider which version you want to use. And we're going to start today. If we want to specify which version we want, we have to search in the tags. The tag is the thing after this colon. So if we didn't specify anything, it will automatically use the latest one. But if we start specifying which version of image we want, we have to explicitly ask for the specific image using the tag. The hated thing is Python has a lot of version, not just only 3.9, not just Python 3, Python 2, not just 3.8, 3.9. Here it has Slim Bookworm, Slim Bullseye, Slim those, Slim that, and a lot of other tags. So how do we select which one we want? Luckily, fortunately, people who develop this image, they have documented what are the tags here. And then they try to explain somewhere how to select which tag version you want here, image variant. So there is Slim version, there is Alpine version, there is Windows Server 4 version. So there are two things you need to consider: the Python version and the thing afterwards. So first we consider Python version. So how do we know which version we want? So we have to go to Python. And then find these releases. This is a place where you come and then check which Python version you might want. If you use Ubuntu, when you type apt install Python, you automatically get 3.8 something. But in Windows, or if you select the version from here, you have the opportunity to select which version you want. Why we want to specify Python version is because every new version, there might be some change that in theory the older code, the code developed with older version of code, older version of Python is supposed to be future-proof. It should be compatible with the new version. But in reality, there is a chance, and it's very likely that it won't work. So if you want to make sure that your code will, your image support this version of code that you write 5 years ago, we have to lock down the version. Even though you write Python, there is a pipenv or pip. There is another way to lock the version down. But using the Docker, the way we lock down the version is we select the image. We select the version here. So that's why we have to first consider which version of Python we want. And we lock this version down, pairing with this project. The project we are going to build, we always use this version of Python. So it will never incompatible forever because we use the same version. So the thing come afterward is a kernel version, or it's just like asking what OS you want to use. Similar way. So there are Windows kernel or Windows OS, similar to Windows. There is and the other thing is different variants of Linux. So this is Linux variants, which is a new thing. So I have to open Linux. Where can I find those? Okay, I should prepare this. Hang on. Okay. So there is not just Ubuntu for the Linux. There is in the Linux or Debian, they have other variants of kernels. If you install Ubuntu, you will have a kernel for Ubuntu. If you use Mac, you have a kernel for Mac. If you use like Android, you have a kernel of Android. So along the way, these kernels develop. So there could be new version of Debian, and they name on here. Like, okay. So these bind with the version of Debian. Just like when you have Android, every new version of Android has a nickname. Oreo, KitKat. Same way, Debian 9 has Stretch, Debian 10 is Buster. So these name means a version of Debian. So when you are looking for a kernel, I highly suggest you use the newest one. So last year I used Bullseye. So this year I will use Bookworm. Which they list at the top. Yeah. These RC and .0b4 is, I think it's like a beta version, alpha versions things. So I try to avoid these sub things. So now I'm gonna search 3.12 because it's the newest one. Okay, dash bookworm. These has bookworm. No. You don't have 3.12 here. 3.12, 3.12. Okay. I'm not so sure about this one. Then I use this one. It should be fine because we haven't developed a code. So basically we just chose a kernel first, and then we write the code that is compatible with this one. So I'm gonna choose this one. So copy this. Okay. Let me come back here. You right click, new file, and then type .docker file. If you type it correctly, this should be a Docker icon. If you didn't type it correctly, then it's not gonna be the icon. If you type it correctly and you don't have this icon anyway, then you haven't installed a Docker extension. And if you have installed a Docker extension, you have this local, but this doesn't show, then you just reopen a Visual Studio Code. Okay. A Docker file here is a script for us to build the image. So we are not going to just pull the image, use it. Now we're going to customize it. A Docker file is the script for building the image. So from now on, with this one, we are not just going to pull the image. We're going to pull and then customize it. The first line to use is from. And if you have the extension, then it's try to make a suggestion that this is what you want from base image. So this is the command from, and then this is the argument base image, which is the name of the image you want to use. And then you start customize based on this one. So I'm gonna use this Python. So this is the name I want. Now I'm going to type in a command. So the container knows what to do. One is run, one is ran, one is run. So I use tail -f /dev/now. I will explain later what is this. But that is crucial that this has to be all in capital letter. Okay, now that we have these two lines, make sure you save the file. If you haven't saved, this will become a dot. And if you save, then it will not become, it won't list as a dot. You use Control-S shortcut to save, or you use whatever you like file save. Now we're going to build this image. So I'm going to right click on the Docker file and then build image. Then this will prompt asking what should be the name of the image. So now it's suggesting bootcamp because this image, this Docker file stored inside a folder called bootcamp. Okay, I couldn't go with bootcamp, so I will just type enter. Okay. So these to show. So this is where it's building the image. And then now when you go here to Docker, you will have the image called bootcamp. And if I want to use this bootcamp, I have to run this bootcamp. So I right click, oh, remove, no, I don't want to remove. Okay. So for now, we go to the terminal. Make sure you are here inside this folder. You type Docker run bootcamp. And when you run the bootcamp, the container spawn. I want you to make note that when I run the bootcamp, I don't have my terminal back, or in this behavior, this command does not return me the terminal. If it's return me the terminal, then I should be able to type a new command. But this one, I'm stuck because it doesn't return me the terminal. So I cannot, so this one is now become Docker run bootcamp and no longer do anything. I have to open a new terminal if I want to if I want to issue a new command. I want to compare with this. So if I Docker run Python, it's returned me the terminal right away. And what happened is the Python here, when I run the Python, there is a new container called Python. But this is the icon indicate that this container no longer run. It stopped. So I run it again. Now I have a new container that's nothing. It just stopped. If I try to run or start the container again, I can right click start. The container did not change. The icon did not change. But the bootcamp has this icon indicate that this container is still running. And if I try to Control C from this terminal, hello, oh, hello. I know it's crashed. Okay, so if I close this terminal, then oh, why? That shouldn't happen. Okay, I'm gonna stop first. I would like to do another try. Bootcamp. Okay, let's see. No. Oh, this shouldn't happen. But if I exit this command using Control C, the containers is supposed to stop. That's what I want to show you. And I'm going to try to explain you this command, but I can do that later. For now, if you want to write Python, we're going to use this container environment to write a Python. Right now we have a container, but we haven't used the container environment. If we want to use the container environment to write a Python, okay, let's start with this. I can attach the shell. You can right click, attach the shell. And when you attach the shell, you will land in here. Make note if this is just sh, then you might need to type bash. But if it's already bash, then you don't need to type bash. Make note that this is now root at some hash string, which is different from my usual command line interface. I usually have this sort of thing. And if you use Ubuntu or if you use Mac, it should be different because it's supposed to be your name. But this one become root because now we are not using the terminal of your host, but we are using the terminal in the container. So when I say when you run a container, you basically have a new machine. This is like you are now using that machine. Okay. So here I can type Python. -v. Oh, okay, that's Python 3 then. If I type Python 3, then I can use Python, which is different from my command line here. If I'm here in my computer, type Python 3, I suppose you have nothing. Yeah. So Windows is just trying to suggest something, but I don't have Python 3 in my computer. But because of this is inside the container, so I have Python 3. So I can start writing Python and running Python using this way. I have Python to write. I'm gonna try show you the old style writing code. So vi main the py. No vi. Okay. Okay. Main the py. Right. So just to show that you can run Python. So now I create main.py and then I can use Python to execute this script. This proof that you have Python. That's all I want to say. Right. Now I want to show you that if I stop using this container and I destroy this container, okay, I'm gonna destroy the other first so it doesn't confuse. So this is the container. I just write main.py, but it just stopped. Then I start it back. I attach the shell. I still have main.py because it's the same container. It's just like you have a new machine, install Python, buy a new laptop, and then you write main.py, you save in the hard drive. When you come back, your file is still there. Then I gotta throw away this laptop because I'm rich. Then I'm gonna run a new bootcamp, which I have a new laptop now. Then I try to attach the shell. Then I try to run the main.py again, but I don't have main.py because now this is different laptop. This is a new laptop you just installed because I just freshly run the bootcamp image. So there is no code. Okay. So at this moment, it's not healthy to develop the code yet. So we're going to install the other tools to help us have a healthier life. So I'm gonna use a new file, type docker compose.yaml or yml. It's the same, but I'm gonna use YAML. If you type it correctly, then this is what you should see. Docker icon with rate. So Docker, from now, we're going to use Docker Compose to control the Docker image. So instead of we build the Docker image by right click here and try to manage the container that way, we're now going to use the thing called Docker Compose to help us manage the Docker container and image. It's a config, so the file will be long. I will send you the template I usually use and then we modify it. So let me open my usual Docker Compose. If you're not in the Zoom, then you can just type quickly now. This version, it doesn't matter. And I'm also not sure what this is supposed to mean. But what is matter is here, services. And then inside the services, you have to name the service. So I'm gonna name this service as dev instead of Python. This image tag is the image name. So previously it's bootcamp, so I'm gonna use bootcamp. Latest, so it's the same one. And this is a build tag. This is the same as you right click, build image. This one is the same, but instead of you right click build image, you ask the Docker Compose to run this for you. And then I'm gonna comment this first. We come back later. To comment, you put down the chart. It's the way to comment. Or if you want this, then you basically highlight the line you want to comment. And on your computer, you use Control \. Then it's going to activate the multi-line comments. If you do it again, then it's uncomment. So you can comment and uncomment quicker. So I'm gonna comment this first. Then I'm gonna clear my Docker. So I have this image, so I'm gonna remove it. You don't need to clear, but I clear so that we are not confusing when I'm trying to explain. So now, when you are ready, you right click this one, and then you use compose up. So I use compose up. So this is a similar text you see when you use Docker build, but this is a bunch. This is a new thing that's come with the compose up. So once it's built, the image is automatically run, and there are two things happen. First, there is this thing network, and the second thing is it start the container. So at this moment, when I go back here, then I see my Docker, I see my container running. But it's slightly different because previously this is not bootcamp. It's some containers, but now it's a container inside this bootcamp project. So with Docker Compose, it will grouping all the container into one project instead of every container living in the same level. Now it's have like a folder for the container to live. I think I can show you. If I just run the image this way, run. No, we shouldn't have him. He's supposed to live outside. Or I can do, let me Docker run hello world. Okay. So previously, all the container we run live inside the individual containers, just some containers. But if we use Docker Compose, now the container is grouped into a container called Bootcamp because we are executing this Docker Compose inside this Bootcamp. So Docker Compose automatically grouping the container for you. If you have like other container you want to use in these projects, those containers will live inside these folders. So if you have another projects like machine learning projects, other courses projects, all the container of those projects will live inside one folder instead of listing in the individual containers. So that's one thing for Docker Compose. Now we're going to develop the Python, but I don't want you to use attach shell anymore. We're going to attach the visual code to the container. Okay. Oh, we don't do that. We right click Docker Compose and compose up. Okay. What you need to be careful is this indentation. This indentation has a meaning. So this def has an object or a variable image and build. And this build has context and Docker file. So you have to make sure that you indent this one. So it's a part of build, not a part of def. So indentation is you have to make sure you've got the indentation right. นี่ต้องเป็น Docker file ครับหรือว่าจะตั้งชื่อนี้ว่า test ก็ได้มันต้องตรงกัน
I thought the Docker one also be used on the previous one also.
Community basis equal 1. Parsing blocks inventory are not allowed. Context. Oh, context has to be done.
Dot.
Yeah. Let me try. Okay.
So even if I run Docker run bootcamp, it does not go that place in the right one on the application. Like it doesn't work. It just feels something like this. Like if I go here and if I do Docker run bootcamp, it does like it doesn't run.
Or we don't run bootcamp here. We have to build first. Yeah, you have to build first. You have to right click the image first.
Oh, okay.
And once you have, and then this will ask for the image name you're going to build. But that doesn't matter now because this is not the way I want you to do it.
Okay.
We're gonna use Docker Compose. You got Docker running, yes.
The over here Docker.
Oh, okay. But can you follow? Can you catch up? I'll come back. Okay. You make sure that the build contain context and Docker file by indenting this once. The indentation can be done using a tab, or you can do 2 space or 4 space. But tab. Then make sure that the context is dot, and the Docker file here is the same as this file, the Docker file, exactly the same. So if you didn't name .docker file, like you name ASD, then the Docker file has to be ASD. It has to be exactly the same because it's requesting, it's finding this file. So the file name has to be matched. And now I'm going back to this one. Right. So I hope everybody can right click, compose up, and then you have this bootcamp with the bootcamp running. Then we're going to actually deving a Python now. But previously I showed you the old way by right click, attach shell, and then start writing in the shell, which is not a healthy way. Now we're going to attach the Visual Studio Code. So we can use Visual Studio Code to write Python instead of using Vim. You're gonna need another extension. So go to extension, find this one. No, I think it's called remote. Yeah, I think this one. There will be a lot of things, but this one, if you click it, it's like a bundle. It will come with like 4 extensions together instead of you individually click this one. If you don't know, well, you should know, but now I know, so we need this one, remote dev. So you find remote development. It can be trusted because it has a logo here, an icon, trusted. So you just install this one. Okay, now you install it. You should have this new icon if it's installed. If you don't have one, then you reload the window by close the Visual Studio Code and open it again. Or you type reload window, which is basically restart the Visual Studio Code. Right. If you have the extension and then you have this Remote Explorer things, when you right click the container, this menu will appear. Attach Visual Studio Code. Earlier, previously, we only have attach shell, but now we are able to attach Visual Studio Code. So you click this one, it's going to have some warning, then we do it ourselves, so we trust it, so we got it. And then a new Visual Studio Code window will prompt, and then you wait for it to set up. And you have to start first. Something is very wrong. Okay.
Okay.
Okay. Right. So can everyone attach the Visual Studio Code? Okay. I'll make sure everyone can attach first and then we move on. Okay, so everyone can attach Visual Studio Code to the container. Then you have a new you have a new Visual Studio Code window separate from the other one. So this is the one we just used, and this is the one is just freshly from this brush. To make sure that you are in the container, you look here. At the bottom left, it will say container bootcamp. So if it's like this, then you are in the container. This visual code attached to the container environment. And then we use this just like a laptop. So I'm going to open a folder first, but instead of it showing me the GUI to select the folder, now it's just this. Because we are not actually using, the right term to say is we are remotely using the container. We are remotely, remote, this one, this remote. So we are not actually sitting in front of the container, just like we are not sitting in front of our laptop. We are remotely using the container. The remote term here is similar if you have used like TeamViewer, AnyDesk. You are not next or in front of that machine. You are remote to that machine. This is the same thing. We are remote to the container. So we don't have a GUI. So I have to. So this is the part. If you are not familiar with the Ubuntu or Linux world, then this is the part name. And this is the first slash means the root of the entire container or the entire Linux, entire OS. It's just like if you are Windows, then it's just like you have in this one. This is the root, the first, the most upper part of the storage. So what I want is I want to be in the root folder. Right. So now in the root folder, I'm gonna create a new file, and I'm gonna name it main.py. Immediately, the Visual Studio Code will suggest you to install a Python extension because we open this main.py, and because of this .py name file name, the Visual Studio Code recognize that you are going to write Python, but it's not yet understand Python. So it's prompt you whether you want to install Python extension. So yeah, I want it. So I'm gonna click install. Then it's, instead of I have to manually come to extension tab, type Python and install the extension, the Visual Studio Code automatically run the script installing the extension for me. Right. So now we have Python extension. So the Visual Studio Code understands Python. So I come back to main.py. If you want to verify that your Visual Studio Code is actually understand Python, you look at the bottom right. Here is say Python, and here is say indicate the version of the Python, which is correct version because we installed 3.11.4. Then I'm gonna type the Python code, print hello world. I save using Control S. just like normal text editing. And if I want to execute this file, I can use run and choose this one, run without debugging. So it will automatically launch a terminal for you. And this is basically the same as Python 3 main.py. It has just absolute path. So it's indicate all the path instead of just use it ambiguously. It's just absolute path. If you don't understand it, just ignore it. It's the same as this one. So we execute the hello world, this main.py. Which means that now we are writing Python. Now you are become a Python developer. No sharing, you're not congratulating yourself, able to run Python. Okay, but this is not yet finished. We still have problem to fix. We are not going to in-depth writing Python today. You make sure that you properly have Docker environment to run Python. So we go back to Docker. So let's say this is finished. Now this is the code I want to write for today. So I'm gonna just close this one. When I close, I come back to the first screen here. Then I'm gonna compose, I'm gonna stop my container. Because I don't want this container to run in the background. If I want to play games, something, just stop the container and basically no more Python for you. You are now having just a regular, normal laptop, no more Python. Okay, so let's say now is the next day, I come back and want to continue writing the code. So what I'm gonna do is I make sure that my Docker is running. So now my Docker is running. Okay, let me start from the beginning. If I just don't have Docker running, I'm gonna quit Docker. Okay, so let's say I just restart my computer. So this is freshly boot. I open my Visual Studio Code without knowing that my Docker is not running. Then if you click Docker, then this message says cannot contact Docker because Docker is not running. So I have to come back, launch the Docker desktop. Okay, so my Docker is back. So I'm back here, click this refresh icon. Then it's updating the information itself. Now I'm going to attach the Visual Studio Code back to this container to continue my development. So I right click, start. Now I start, right click, attach Visual Studio Code. And it's come back right where I left. So I print. So this is very cliche text. I am learning Python. Okay. So I make a new code. I execute the code using the same command, run without debugging, but this time I'm better because I know this is a shortcut. So I use Control F5 and then it's run Python, it's run this file for me. So now today I have these two. So what is the problem then? Because everything works like we expect. The problem is this file .main.py is inside the container. Just like we have a new laptop, we write the code in that laptop. So the code is in that laptop. In our host, we have no access to the main.py. And we have learned earlier that if I destroy this container, right click, remove, the main.py is gone. Everything we worked 2 days long is now vanish away along with the Docker, along with the container. So we want another one. We want another things. We want to map the thing called volume so that the container and the host has the share folder. So basically, we allowing a Docker to access the folder in the host. That is called map the volume. So the term for the Docker, they say map the volume. So when you come back to the compose, I'm going to destroy everything now. To destroy everything, I use Docker compose down. So because I haven't closed this one, it's lost the connection to the container, so it has a message. Don't worry, just close it. If you use Docker compose down, then the container and that folder bootcamp is gone because we basically destroy the entire project using compose down. Why we want to compose down? Why we want to destroy the container? Because we want to make sure that every time we build this project, it runs. That's what we want. We want to be able to, we want to write this code and write this Docker file such that we are no longer afraid of Docker compose down. The next time when you come back, you right click, compose up, you continue the development. That's what we want. So we are not afraid of destroying the container. So if you're still hesitating to click this one because you're afraid of your project might not run in the next compose up, then you have done this incorrectly. So you have to be able to compose down confidently. Okay, so now we're going to map the volume. So I will uncomment this volume. And then I'm gonna list down the folder I want to share from the host to the container. What you want is you want to another line, tab and dash. And here, the Visual Studio Code lists a suggestion that the left one is the host part and the right one is the container part. So this one will be the folder of the host. So I'm gonna name this folder source code. And make sure that it starts with /. If you don't use /, this source code will be somewhere else. Remove this. Okay, there is no confusion. So we're gonna write /. This is crucial. You need to have /. So your source code will be in this folder, not somewhere else. It's a relative part and absolute part things. Then we make a colon, and now we're going to indicate the container part, where this folder will be mapped into the container. Earlier, we go into /root. So I'm gonna map this folder into /root. I'm gonna name it code. Okay. I'll do this way because I want to show you that these two folders can name differently. But it does. But if you want to clear the confusion, then I normally use the same folder name. But I'm gonna show you that it doesn't matter. It can have different names. Okay. So with this, when I compose up, I will have .source code next to these two files folder. I will have a folder source code next to these two files. And in my container, there will be this folder /root/code. So I'm gonna compose up again. So immediately after the run, I have source code. And then I go back, attach the Visual Studio Code. It's going through the same process as the first one because it's trying to. Oh, yeah, okay. It has to reinstall all the Python and everything for you. Just remember. Okay, just wait until this one is stop having. Okay. So now it should be ready. If you're not here, then go to File, Open Folder. Make sure you / the Open Folder root. And what you should see a folder code. Previously, there's no code, but now there is a code. So I'm going to create a file here, main.py. Rewrite my code that I just accidentally destroy. Hello world. Hey, hello world. Okay. Right. So now I have main.py back because I just redeveloped it inside this code folder. What I want to show you is if I close this window, I minimize it. I come back to this visual code, the host one. And inside the source code, there is main.py. This main.py contains the code I just wrote because it's basically the same file. If I write here, save, in my container, update it because it's the same file. So it's basically the container has access to this folder, source code. So it's the same file, it's the same folder. If I remove this main.py here, it's basically I remove main.py from the container. When I say it's from the container, it's wrong because this container had access to the host. So there is no longer main.py because I deleted it. Okay, but why do I delete it? Because I want it. Okay, I have to rewrite it again. Print. Hello world, W. Okay. So with this, I am confidently destroy my container because now the code is not inside the container. The code is inside my host. I'm just allowing the container to read this folder. So I'm not afraid of losing my file again. So I just compose down because I'm done for today. So I'm gonna compose down. Okay, my container is gone. And if I close my computer, close my laptop, come back again another day, come back and want to continue developing this project, all I want to do is right click, compose up, go back here, attach the visual code. Now my main.py remain. Nothing is lost. Well, things lost, but my main.py stay here. Yeah, a lot of things lost. It's not clear because the Visual Studio code is too good to remembering at everything, but what is gone is the extension. All the extension we install, like Python and everything, is gone when we compose down the container, when we destroy the container, all those extension is gone. So every time I compose down and compose up and attach the Visual Studio code back, there will be a slight, if your computer is too fast, then you might not see it, but there will be a slight execution of downloading the extension again. So I'm going to show you. I want you to pay attention that this is happening. Okay, compose up. Okay, so this is a new container. It does not have the extension. So I right click to show you. I'm gonna right click without attached again. And here it say installing server, starting server, and at some moment it will start installing these extension again. So now what I want is I want to keep this extension so that next time when I compose down and compose up, I don't need to wait for the extension to install. So in the same sense, we're going to map the volume. So this extension exists in the host folder, and then we allow the container to store this extension. So it's persists or not destroy. So now I'm going to compose down. Oh, before we do that, we have to know first. Okay. So the question to ask is, where is the extension installed? Well, I just know it's installed here. This is the folder where the extension is installed. So we want to map this folder. Instead of this folder create inside the container, we want to map this folder to the container. So I'm gonna copy this folder name. I'm going to compose down. Then I will add a new volume. Right, this one space is fine. Okay. So to add a new volume, you just make a new line, make a new dash, and then space, dot slash, and then you're going to name this whatever you want, but I'm going to name it the same now. So I won't confuse myself in the future. I'm going to name it VS Code server. And then I'm going to map this folder to the container at this root at this VS Code server. Okay. Now I'm gonna compose up. When the container starts, I have VS Code server here next to the source code. Nothing happened yet because we haven't attached the visual code. So I'm gonna attach the visual code, and then I'm gonna monitor this VS Code. At this point, this VS Code is trying to install libraries, extension, everything it needs for you to attach, for you able to attach successfully all the library it needs. And all of those installations are stored here inside the host machine. Yeah, of course. So here, extension, Python are installing. Okay, I'm gonna wait for this to finish the extension installation. It takes forever. It shouldn't be this long. What are you doing? Okay, while we're waiting, I'm gonna keep explaining. Because we map the VS Code folder like this, so the next time when we compose down and compose up again, this Visual Studio Code does not need to reinstall everything. It does not need to spend time. We will not need to spend time waiting for the extension to install again. Once we attach it, just run. So it doesn't matter that much to keep this extension persist, but I want you to practice this. So the next time when you have, so the next time you can manage what you want to store inside the host and what you want to keep inside the container. So every time when maybe you're not writing Python after you graduate, you can write something else. The same fashion like this, you should not be able to afraid to just map volume. Whatever volume you want, just map it if you want to keep it. Why is it so long? I have to check because sometimes AIT like to kick me out of the internet, even though I'm using it. Anyway, so this is nearly the end of setting up the Docker. So with this, what we have done, all we need to do when you want to start developing a Python project, instead of writing the Python or instead of installing a Python in your host, I'm introducing you to the Docker. So you can have a virtualization. Instead of having a specific Python, you're virtualizing a Python. And then you are free to change the Python version from here. And this Python is not living in your host. So if you don't want Python anymore, all you have to do is just destroy the container, remove the image. Yeah, the best and the another benefit is because we specify the Python version here, we specify from today. So in the next 5 years, when you want to come back and rewrite or come back to continue to develop this source code, in the next 5 years, you might already forgot everything about this project. So you don't even remember what Python version you need to install. But with this, because we note it down in the Docker file, you will never forget what version it is. Or even though if you don't care, this project will just use Python 3.11.4 because we use this Docker file, we use this Docker image. And the best thing of it is right now, with this Docker, with this container, with this Docker file, Docker compose, with this source code, if you send these 3 folders to your friend and he has a Docker or she has a Docker, all they have to do is right click, compose up, and they basically have the same environment to run the code. No matter what machine it is, if it has a Docker, all they need is these 3 things to run your code. No more call to your friend. Are you installing the correct version of Python? Do you have this? Do you have that? Do you have SQL yet? All you have to do is build a Docker file, and you are no longer afraid of compose down, compose up. If it's work on your machine, it will work everywhere that has Docker. So we removing those headaches from a developer, because that's the pain point of writing code. You might not feel that if you're not you haven't developed a code before, but it's a real problem. Okay, my Python is done. Okay, the last thing we're going to do is we're going to write the code. We are not gonna write Python. Because you are DSAI student, and writing Python, and if for a data scientist, you want to be able to run some section of code again and again, changing things. You want your code to be more interactive. So this way, it's not interactive, because when you make some change, you have to re-execute the entire code. And let's say these 2, in the real scenario, maybe these 2 lines of code takes 10 minutes to run. And all you want to do is make a new line and see what it does. So when you make a new line, you want to see the effects, you run the entire script, you have to wait for these 10 minutes to finish the execution. And then you can see the new line of code. But if it's a bug, this cannot run. So you have to come back, fix the bug, re-execute, wait another 10 minutes. This loop continue. So we want this to be more interactive. We don't want to re-execute this every time we want to make a quick adjustment. So what we're going to use, instead of just Python, we're going to use Jupyter. And all you need to do is go back to extension, find Jupyter, and then install the Jupyter. And then we wait again. Okay, okay. Some of the extension need reload. So if it's asked for the reload, you just click it. Okay, so now I'm ready. Now my Visual Studio Code has become a Jupyter notebook. So to start writing to start accessing the Jupyter, what you have to do is create a new file, name whatever you want, but the extension name has to be .ipynd. So I'm gonna name it experiments experiment 1. This is crucial. You have to name it .ipynd. If you name it correctly, then this icon change to a notebook. And when you create it, instead of just a text, it has some GUI now. Okay, so I hope you can see a Jupyter notebook now on your machine. The first thing we're going to try is write a Python code, just the same print. And then we're going to execute this, but instead of using run debug here, we click this one. This is execute the cell, so it's only execute. It's going to execute this code. If you have this prompt, because of you haven't selected the kernel, so we're going to select the kernel. Previously in the main.pile, when I open the main.pile, this one mapped the kernel to 3.11.4. This one show because it's mapped to the kernel, to the Python version. But this one we haven't mapped. That's why this says select kernel. So we have to pick the Python version we want to run. So select click Python environment and then 3.11.4. But if you use different Python image, use the one is say recommended, I guess. Then try execute the cell again. It's gonna ask you to install IPY kernel package. I'm not sure how can I make this easy, but it say IPY kernel. If you have this, just click install. And then we wait again. But this will be the last wait. So once you have the IPY kernel installed, now I can run this code. And when I say print, this is the result of the print. Okay. If I want to have a new line of code, I can make a new line, type. No, that's wrong. And then I'm going to click this one. Then actually these two lines is execute like this. Yeah. So what is good about Jupyter is you can make a new cell instead of just a script of code, a sequence of code. You have a block of code and it's just named the cell. So this is one cell. I can make a new code block or code cell. I have another block where I can just type. And then I can run these two sections of code independently. So I make change to this, I run this, I make change to this, I can rerun this code. There is some source of sequence, but the power of the Jupyter is you can run whatever was the cell you want first. But that will be a bad behavior if you just randomly write the code in not in sequence. But you will develop a good sense of writing later. For now, I'm teaching you what is Jupyter. So when the semester starts, you jump right into it. With this is the result of running this code. So if I type something and try to execute it, this is the errors. So it's throw the errors and it's print the error for you. And this error is independent from here. So you can just run this code as many times as you want. And when you run this cell again, it just this error is only affect this code, only this cell. Okay. You can reorder the cell. So here I move the cell upward. And I can execute the cell in whatever sequence I want. You can please note every time you run the cell, there will be this number. This number indicates it's a step of the run. So this is now the 32nd step. So if I run it again, it will be step 33rd. And click again, it should incrementally add. So it means I have run this cell at step 31, run this cell from the step 27, 27, this from 36. So if I run this again, it will become 37 because it's the 37, the click number 37. I can restart the kernel because now I run a bunch of code and then I want to start fresh. So I can click restart. When I click restart, when I execute the code, it will start from 1 because all the step is now clear. All the history is clear. So now if I click, it become 1, 2, 3. I come back here, it become 4. If you want to clear these output, you click this one, clear output. So all the output is gone, including the step. And if you write the code in sequence, what you can do is instead of individually click each cell, when you come back, you can use this one, run all. It will sequentially run the cell from top to bottom. So this will be very similar to writing just a Python script, because if this cell has an error, it will stop executing. So I'm going to show you. Restart here, run all. Okay. So it's run this one, but this one doesn't run because this one has an error, so stop running. But you have a power to just ignore this and continue from here. And you come back and run this again. The power of the Python notebook is not in because you can also have a markdown. So what is a markdown? The markdown is another language. Python is a language, programming language. Markdown is also a language, but this one is for documenting. So I can write, I can beautify my Jupyter. So I'm gonna move. How can I move this? Move. Okay, I'm gonna move this down instead. Okay. So I'm gonna make some hate, or let me show you just text. This is where's right? So this is the notes I want to note down. So whether you have run this cell and then you find something interesting and you want to remember what you think, then you make a markdown instead of writing a comment in the code. Or writing a comment in the code will look like this. I can use a markdown to document, help me document what I want to document. And if I click this, then this will become a nice text printing. And you have the ability to formatting the text. So for example, I can do this. So if I do this, this will become a title. I can do this. I can do this. So it's italic. I can also do this. So it's bold text. And I can do this. Yeah. So Markdown is another language mainly for writing a document. I highly suggest you learn a Markdown along the way when you are here in AIT. And if you want to learn Markdown, you go here and then Markdown. There will be a guideline for Markdown, but the better one is Markdown GitHub. Yeah. So this one is look long, but it's just like a cheat sheet. If you want to do something, or you just scroll through what it can do, what it can does, what it can do, then you're gonna find, okay, if you want to make a title, you need 1 sharp. If you want a second level, you need 2 sharp. You can scroll to see how to make a bold text, italic, strike through. Just spend like 5 minutes scroll through this to see what Markdown can do. And then next time you want to have this, just come back and see how to make a strike through. Like right now, I know there is a strike through. So when I want to have a strike through, I come back and see what is the syntax. Then I go back here and then I make a strike through. So you don't need to remember all of this. What we have to do is go through this, see what Markdown can do. And then the next time you want to have this, just come back and find the syntax. Yeah, okay. So you can put the Markdown wherever you want, like this, like over here. My English is very bad. Then our conclusion. Okay. Then finally, eventually, we will ask you to submit. We might ask you to submit. We might ask you to do a homework using Jupyter Notebook and then submit the results using Jupyter Notebook. You can submit using .ipynd, but a better way is to do here, export PDF. I think it can. Let's see. Let's see. Oh, yeah. Okay. Yes. Yeah. Okay. I hope it can export the PDF for me. Wow, a lot of things to do. Okay, it's able to export the PDF, trust me, but I'm not gonna do it today yet. Instead, I'm gonna show you export to HTML. Okay, so when I have the HTML, I can go back to, because it's here in the code, I can go to my projects and I can see my HTML file. So I'm gonna open this. And this is the render version of Jupyter Notebook that you just export. So you can also submit using .html. Another thing I want to let you know right now is instead of clicking here to execute the cell, you have a shortcut. You can use Control Enter to execute the cell. When you use Control Enter, it will execute the cell and stay in that cell. But if you use Shift Enter, it will execute the cell and move to another cell. So if I keep doing this, it will just keep going down. So Shift Enter to execute and move next. Control Enter to execute the cell and stay. Okay, I don't need this now. I have to. If you make a cell and then you change your mind, you can click this one and then change whatever the cell you want it to be. Like I'm gonna make it Python or Markdown. I have the ability to change. Like the use case might be you make a new code accidentally, but you like a Markdown. Markdown, this is the title. You execute and then you realize later this is a Python. You want it to be Markdown, so you change it to Markdown. Now it's become Markdown. In the same sense, this is the Python code. I'm gonna change to Markdown. Now it's just a Markdown, no execute. And I change it back to Python code, Python, and then it's back to Python. Okay. Now I have 20 minutes left before we have a break. This is the final version. So not nearly the final, because this Docker file will continue to develop along the way. You will learn how to customize we will go through customizing the Docker file even more. But for now, this is a start. So I kept that for the future. For now, I have to make sure that you understand the Jupyter more. If you haven't write Python, the Python has a variable. The variable is a variable. There is a variable name. Let me show you the variable. So number equal to 1, like this. So I declare a number and I store 1 into this variable name. So next, I can print number, and it's gonna print 1 because this number equal to 1. Just like in your mathematical equation, you have x equal to 1, y equal to 2. So I have number equal to 1. Later, I can change the value inside the number equal to 10. And then I come back, print number, now it's become 10. So at this point, I hope it makes sense that when we store number equal to 1, we print, we get 1, then we change number to 10, print again, we get 10. And if we also have this in the Python file, python.py script, have exactly this sequence, this is exactly what is printed when you run. But in Jupyter, it doesn't work that way. It seems like it works that way, but it doesn't. So there is this tab, variables. So you click, and it has a table displaying all the variables you have currently at this moment. So if I have a new line, so I'm gonna declare second number. When I execute this line, this table is updated to the second number. So currently at this point, I have two variables inside, not inside, like currently, right now. So I have number and second number, which is type integer with value 10 and 20. So if I change the value here to 50, this update to 50. So now it makes sense if I also print second number, I'm gonna print 50. And if I restart this kernel, earlier we clear all the history, but now we also clear the variables. So now the variable are gone. It's like fresh start the environment. So in order to regain all those variables, I have to re-execute this cell. Up until this point, I'm back to 10 and 50. This still makes sense. But what doesn't make sense if you're new to Jupyter is when I come back to this section. This is number one. This is number equal to 1. When I print, it's equal to 1. This is number equal to 10. When I print, it's equal to 10. It's print 10. So now I'm gonna re-execute this cell. Instead of printing 1, it's printing 10. Because it prints the number that is stored 10, not 1. It doesn't work that way. It doesn't work the way you think that if you think it works as you come back to here and then you think it's going to print 1, it doesn't work that way. Because it has to store a variable somewhere. And then if you see this table, I hope it makes sense now why it's print 10, not 1. So in the same sense, if you restart and instead of running the code from here, you're running the code from here, there is no number because we haven't run this section of code to declare number. So it does not mean when I say you can execute the code independently, each cell can be executed independently. It's true, but it's only half true if you know what you're doing. You can re-execute independently, but you have to make sure that you know what is the current state. So to make a good habit, you should always remember what is this number mean and what is supposed to print, what is the current state, and try not to like jump around. It's help you debugging your code. So this one, this table, this one. Okay. When I first writing Jupyter, this is the most thing I'm confused with. So I'm here to tell you what I have been confused before. So you are not in the same scenario as me. Okay. So let's say I have done my experiment 1. So I'm going to make sure that my code, my Docker will work tomorrow, even though I compose down. So I close that window, come back to here, compose down. And compose up. Pretend to be the next morning. Right, come back here, right click, Visual Studio Code. And I shouldn't install any extension here. Yeah. I don't need to install extension, everything continue as is. So I'm trying to execute this file. So this is, when I say it's the last step, this is not the last. Because earlier, when we run Jupyter, we have to install IPY kernel. This IPY kernel is not the extension of the Jupyter. It's not the extension of the VS Code, but it is a pip package, pip. So, okay. Let's say it's a library. So when you want to have I'm not so sure whether you are familiar with libraries, but libraries are the thing people who have developed write a code and left it somewhere, actually a repository, and you want to use that libraries, so you don't need to rewrite everything. That's its libraries. So in Python, if you want to download Python libraries, we use pip. Pip3 is the package manager, another term, but it's help you maintain the pip package or the Python libraries. So I can use pip3 to install Python libraries such as NumPy. Then it's gonna download NumPy, and then I will have NumPy. So earlier when I'm trying to execute this cell, it's prompt me the window of installing IPY kernel. What it does is executing pip3 install IPY kernel like this. So you can do it manually. It's the same. It's because it's already installed, so I don't need to wait for this bar to complete. And if you want to see all the list of pip you have, you use pip3 list. If you print all the packages you currently have. I just install NumPy, so NumPy is here, along with the version. IPY kernel is supposed to be somewhere. IPY, what? Oh, here. Another famous library is pip3 pandas. Okay, so now I have pandas. So when I come here, if I want to use NumPy or pandas, I can just import NumPy. It has NumPy. Import pandas. It has pandas. I can group it together. Actually, it's a better way. Then I can use NumPy.array. Wait. Right. So why do I have to show you this? Because now if I want to use NumPy, because I pip install NumPy, I can use NumPy. But pip package live inside the container. So we come back to the same problem as earlier. When we compose down, all the pip package is gone. And when we come back, we have to reinstall those packages. Now it depends on you whether you want to persist these packages. So there are two ways you can persist these packages. So you don't have to reinstall these packages every time. The first way is we redo the volume. So in this case, you find where the pip package is stored in the container and you map those volumes. So those packages store in your host, and the next time when you spin up the container, you automatically have those packages. But here I'm gonna show you the other way, which is the way I want you to do, is customizing your image. Because you need IPYNB kernel, you need NumPy, you need pandas. So we want to make sure that this image, once we run the container, it has those packages right away, instead of have to manually install it later. So what you do is you run pip3 install IPY kernel, run pip3 install NumPy, run pip3 install pandas. Okay. So now we have a new command. The command is called run. So this run, the argument it takes is this text, which is the same command we use in the terminal here. So I just use pip install pandas. So if this command can run inside the container, this can run here too. So it's just a shell command. So you can run anything. You can run Python 3, main.py. This is also possible if you have main.py to run at this step. But we come this far, no. When we install like this, we will get the latest pip version, or what version pip thinks is the best. But we come this far to lock the version down, the Python. So we also want to lock down the NumPy version and the pandas version. So what I usually do is I'm going to store everything here. The thing I need, I keep, this is iterative. I will not know I need pandas from the beginning, but when I need, I'm gonna pip3 install pandas. And then I'm gonna see what version it is. You can see it from to check. This is the way I check. So pip3 list and find pandas, and this is the version. So I'm gonna lock this version down into the image. So I copy this to 0.3. To copy, you highlight, and then you right click. Then you come back here, you type equal 2.0.3. The next time, tomorrow, when you build this image, it will only download this version of pandas, no matter when, no matter how long. In the next 5 months, when you build this image again, it will use this version only. This makes sure that you will never have issue with conflicting the library is too new or whatever, because we locked down the version of the libraries. So in the same sense, I'm going to do it in NumPy. But I'm going to show you the how to make this easier. So if I want to find NumPy, I do pip list and I'll scroll, find the NumPy. If you have like 100 libraries, you scroll forever. What you can do is you pip list, you pipe. This vertical line is called pipe. This is the things, the key is above the enter. This pipe is above the enter on your keyboard. If you cannot find the pipe, it's leave above the enter key, or below the backslash, the backspace. So you type pipe, and then next we're going to do grep and the library name. So in this case, I want NumPy. So when I enter, it's only print NumPy. So I don't need to find NumPy in the list. So I copy the version, right click, and then lock down the version. PY kernels is only needs for the Jupyter. I'm not gonna lock it down. It does not need to be locked down. Later on, you will be able to decide yourself which you should lock, which you shouldn't lock. But for now, I won't lock a device kernel. I only lock these two. Okay. Then I continue developing. Eventually, then I know I have to use sklearn, so I have to import sklearn. Then I don't have sklearn, so I have to come back to the terminal, pip3, install sklearn. And I install sklearn. I think I have to install scikit-learn. Okay, then I'm gonna document this by list and then scikit-learn here. Copy this, come back here, run pip3, install scikit-learn like this. So you are not I hope you can see that I'm not rebuilding the image every time I need a pip. I just keep like I'm note down which pip I need. So I can just keep now at install scikit-learn. I have sklearn. I can use sklearn, and I can just keep developing. If I need new libraries, I keep install. Then I come back here, put the new pip here, come back, keep writing. And when you finish today, I close this down, I go back, compose down. Can you be more faster? Okay. Then pretend to be tomorrow, come back, compose up. Automatically, the Docker install the pip during the build. So now we just wait. What I want you to make note is there is this catch text in front of one of the steps. The Docker has a cache, so you don't need to reinstall the pip every time you compose down, compose up. So this should be only one thing, one-time things. So I can show you. It takes time to build this. It takes some time to build this, but that will be. It's supposed to be the only time I am waiting for the pip. So if I compose down, please stop, please. Stop. Okay, I compose up. I don't need to wait through these pip because it's already cached. You can see it's as a good thing because you don't need to spend time waiting for this. Or you can see it as a bad thing if you want to change this IPY kernel or whatever, you have to somehow delete the cache. Or if you're expecting this to be the newest version possible, these cache will just reuse the cache. You never change this line of code or this line of run. But for now, this is how you lock down the version along the way when you're developing the code. And if I attach the visual code, because I persist the extension, I persist the code, I rebuild the image such that it has all the libraries I want to use. When I come back, this code will just run. Right, it just run. Earlier, it has to prompt me install IPY kernel. because I install IPY kernel, I install NumPy, I install pandas scalar. Since the building of image, so this image come automatically with those libraries to use. So the decisive why I am putting the pip as a run in the Docker file instead of use as a volume, because I want this Docker file, this image, to contain the pip. The difference here is this volume is not in the image, but it's in the container. So this only exists when you run the image and it's become the container. And at that time, it has this source code or this and this VS Code server. So you can imagine when I want you to imagine when you want your friend to run this code too. When you send this Docker file along with the Docker Compose, if they don't have the source code here, if you don't send them the source code, they will still be able to build this image. Because they don't have the source code, they have no access to these main.py, these experiment1.py, but they have access to this pip. Right. So the decisive, the decision here is if I want this image to embed it with these libraries, I put the changes here, or persist the package this way instead of mapping the volume like I used to do earlier. So okay, so this is actually final version. And then along the way, when you start the semester and then you need another pip, you repeat this step. You pip inside the container, you document it here. And then tomorrow when you rebuild the container compose up, your image will be embedded with the package. And now you are no longer afraid of compose down. A bigger picture is you are no longer afraid of losing your entire computer. As long as you have access to your source code, Docker file, Docker Compose, these just text. They are just a text. You can keep this in your USB. You can, and in this afternoon, I'm going to push this into some cloud in the GitHub. So a bigger picture is if you lose your computer today, like after the break, your computer is just gone, it doesn't run because we just installed Docker. If you still have these code, these texts, you buy a new computer, you install Docker, and then all you have to do is right-click, compose up, and then you get your code back in development. Your downtime will be just a matter of you have money to buy a new laptop. So the key to do this is make sure that no matter when, if you have these things, you will back developing the code right away if you have Docker and these three things. Okay. So it's already noon. Let me wrap up very fast what we just did. What we have done this morning is we install a Docker. For Windows and Mac people, we use Docker Desktop. For Ubuntu, there is something we need to. I think Docker Desktop doesn't work on Ubuntu yet. So we use this. So you have an access and control of the Docker. We install the Visual Studio Code, which is the final IDE you need because it's adapt to everything you want. So I install a Docker so I can interact with the Docker using VS Code. and I can start writing my Docker file, Docker Compose, just a matter of right-click things, selecting the menu, and then I have the Docker container to run. We built a Docker file. You learn how to select a Python version, Python image from the Docker Hub. For now, we just put this like this. We make a Docker Compose to help us manage a Docker container as a project. And we learn to attach the Visual Studio Code. So instead of Vim and things in the terminal, you have a graphical interface and IDE that use the Python environment inside the container. We learn to map these volume. We learn to customize the image using Run. Yeah. Yes. We spend 3 hours understanding this, but the next time you have to do this, you would use like 10 minutes because you already know what to do. You just copy this code and change things. It takes 10 minutes. Okay, so do you have questions? If you don't have, I'm gonna end the meeting and then we come back this afternoon at 1 p.m. So we have questions? Oh, okay, I hope you fix this. Okay. Okay, so no question then. See you in the afternoon.